back to another ECE 2100 video. Today we are working on lab number 5. This lab will be dealing with phase shift magnitude of your circuit. Alright, so I'm assuming that you know how to hook up your signal generator to your 3 bus ports and to your oscilloscope. You can go ahead and hook them up right now into the configuration that we want. So far you need 1 signal in and 1 signal out. So you're measuring 1 and reading 1 in. So let's get our circuit set up. Right here in front of me is our circuit already built, and we are going to hook up our signal generator leads. So for this one, we want to hook it up to the 0.1 micro, and we're going to hook this one up to our ground. In this case, my ground is right here. And we are going to, this is a little bit of a different setup than the one you're used to. So we are going to use our oscilloscope without a bus to measure our input signal. So I'm going to use my oscilloscope to measure the exact same thing. You won't have to do this, you will only have just the input signal, and that will be that. All right, there we go. Now we are going to take our second oscilloscope lead, which is our output lead, and we are going to hook it up to our circuit with our ground in the same location and a positive in our 150 pico capacitor, which is, in this case, really small. There we go. And then we want to hook it up to the ground. There we go. Now on the oscilloscope, we want to hit auto. And that is what our function looks like. This oscilloscope is different than the one you're used to. However, they should all function the same. So for this one, we want to measure magnitude and phase shift. So in order to, we'll start by measuring magnitude. We want to expand our horizontal until we could get a nice, pretty look of one waveform. Something like this. So for the purpose of this video, our yellow line will be our input line, while our pink will be our output. So how do we get our phase shift? Well, Dr. Trombetta or Dr. Clayton, or whoever is currently your ECE professor, will provide you an equation, which is delta phi over 360 is equal to delta t over big T. So delta t is your shift from peak to peak, or trough to trough, whatever you may choose, your amount of time it takes for that, while big T is your period. So your period is already known because you already have an input frequency of 3 kilohertz. So you can invert that to get your period of whatever that may be. So so we only need to find our peak to peak in this case. So how do we get our peak to peak? Well, we are going to turn on our cursors, which I hope you're all familiar with now. And we're going to set our first cursor to our input line. Right, so we want it right in the middle of the trough. So right in the middle of the pink. I believe that looks good. And then we want to get our second cursor, and we want to put it on our output, or on our input. We put the first cursor on output, second cursor on input. There we go, that looks good. Up here, you'll see our delta x. You want to pull that value. Then you can, now that you have delta x, you're given delta t by your frequency, and you have 360, you can now solve for your phase shift. So then running from there, you'll get your phase shift. Now, the problem is, how do we know if this phase shift is positive or negative? There are different conventions for this, and in this case, for the purpose of this lab, we are assuming that if our output signal is coming before our input signal, then our phase shift is positive. While that basically means that if our output signal follows our input signal, then that means we have a negative phase shift. So if we look back here, when we zoom in on only one waveform, we want to look at our signal, right? So here, yellow is our input, while pink is our output. We see that our yellow is coming, our peak is coming before our pink peak is coming before our yellow peak. which means that we are dealing with a positive phase shift. This convention may change depending on who you're talking to. However, it is nice to know which one is leading and which one is trailing. Now let's find our magnitudes. So our magnitude is essentially our peaks, or peak of the wave. So we want to measure from our middle of the wave, middle of the output wave, to our peak of the output wave. So this is also called amplitude in this scenario, although magnitude and amplitude are slightly different things in real life. So we see that I'll turn off our signal 1 first. And then let me put my trigger down. Let me auto scale it then. There we go. So we'll see that our signal has no offset. And how do we know this? Because we see that our signal is oscillating around this line in the center. That is essentially our 0 line. And then as you'll see for your second or third circuit, there will be a DC offset, so this value will be different. But for now, let's just find our offset, or our magnitudes. So we want to take our first cursor, this guy, and then we want to put him on the middle of that line. So basically the middle of our sinusoid. That looks good. Then we take our second cursor, and then we want to put him at the top of the sinusoid. This will give us our magnitude, which is right, it's about there. I think that looks good. So that means we have a magnitude of about 0.8 millivolts. Note this circuit is slightly different than the one that you will actually be building. So if you attempt to copy these results or this process, or no, just the results, then there may be a different discrepancy. So that will give you your magnitude, and now that you have phase shift, you can go ahead and fill those in on the table. So now let's get to the next part. We have two components. We have two tables we need to fill in. We have one with our 1x probe, and then we have the other for a 10x probe. So currently, each probe has a certain setting. We take a look right here. We see that there's a dial, or a little switch right here, if you will, with 1x and 10x. So currently this probe is in a 1x because it is towards the 1x side. And then when we flip it to 10x, we will change the input or the impedance of the probe, which changes the impedance of the oscilloscope, or how the oscilloscope views the circuit. And then you'll get a slightly different measurement. So we will flip this. So now that we flipped it, let's take a look at our oscilloscope, and we get to see something a little bit different. Our signal looks a little bit more dampened now. So you'll go ahead and auto it again. And then you have your circuit again, and then now you'll take your measurements. You should know how to do phase shift now and how to find magnitude. So if you don't know, go back in the video and find it the same way. It should give you the same results, or does it? It should give you something similar. Maybe it doesn't, who knows? So you'll record those values in your table, and then that will be it for circuit 1. For circuit 2, there is a component of a DC. You have two sources. You have your signal generator source, and then you have your power supply source. So your power supply source will actually change how your oscilloscope views the circuit. So that means that you'll have some sort of offset, because if you think back to circuits 1 or 2, you'll see that superposition, when you add two different frequencies together, you can't do that. You'll instead have two components, and then your DC offset will also be a separate component. So your signal will actually be scaled up or down depending on your source. So I'll give you a mock example on this one. So let's say that this is 0, and then we are actually, this line right here, I'm not sure if you see it very well, there's a X and Y, they intersect at the origin. This X graph, X line, will actually be our 0. So let's say that our circuit measurements actually pop out something like this. So that means that our voltage is actually less than 0. So then you would find that by using your cursor and measuring from your 0 point to the middle of your waveform that you just generated. That should give you your DC offset. And if you're looking for your AC offset, you would use AC offset is your sinusoid. If you're looking for your AC voltage or RMS voltage for your multimeter, then you'll just want to use your multimeter, hook it up like a normal multimeter, which I'm sure you know how to use by now. And then from there, you will just measure your RMS value and then record that in the table. That should be all for lab number 5. If you have questions, go ask a TA or figure it out yourself. Have fun.